Hi, we're going to go ahead and get started with our webinar for this afternoon on hazard communication. Just a couple of real quick housekeeping items. Number one is, I guess the only housekeeping item is I have everybody muted to cut down on background noise. If you do have any questions, please type those into the chat box, and we will get those answered either throughout the course of the webinar or immediately following the webinar. So with that, this is Rich Barcum speaking now. I'm the owner of Cardinal Compliance Consultants, and our main presenter today is going to be Mr. Zach Brown. Zach is a safety consultant here at Cardinal, and he's going to talk to you guys about the ins and outs of the hazard communication standard. So with that, I'm going to go ahead and turn it over to Zach.
All right, thank you very much, Rich. As Rich alluded to, guys, my name is Zach Brown. No, I don't have a band. I wish I did, but I don't. I am a health and safety consultant here for Cardinal. I've had the great pleasure of being able to work with the hazard communication standard quite a bit. Little side note, before I was with Cardinal, I was a chemist for another environmental company, and I was able, fortunately, to get that experience with the hazard communication standard as well. So I've been pretty fortunate to have different types of experiences with the hazard communication regulation, and I'm happy to be here today to talk to you guys about it as well. So the first thing we need to talk about is, what is the hazard communication standard? It's also known as the HAZCOM standard. You'll hear a lot of people refer to it as HAZCOM instead of hazard communication. Still same standard, everything like that. But the HAZCOM standard, the point of it is it gives employees the right to know. Basically, it's there for the employees to give them the right to know. Well, what does it give them the right to know? It gives them the right to know about the chemicals that are used in the workplace, possible dangers you could be exposed to from those chemicals, and then most importantly, how to protect yourself and their coworkers as well from those hazardous chemicals that or any of the regulations that fall within the HAZCOM standard. So, moving on from that, so we've talked about what the HAZCOM standard is. Now let's focus on who's covered by this. Well, the most common, two most common industries that are covered pretty much by every OSHA regulation we all know are the general industry and the construction industry as well. Now we also need to think about those shipyards, those marine terminals, and longshoring as well. They are also covered. Now more specifically, with this HAZCOM standard, it calls out chemical manufacturers and importers. There are certain regulations that they also have to abide by, which we'll get into. This is definitely geared more towards them. All then, of course, the employers and the employees that are exposed to chemical hazards within the workplace, which chances are is everybody who is listening to this webinar. Okay, so why is the hazard communication standard so important? Well, back in May of 2012, OSHA revised the HAZCOM standard to align with the global harmonized system for better classification and labeling of chemicals. Now, OSHA recognized that there were some serious issues with the current HAZCOM standard, and that is why they made, at that time, that's why they made the changes in 2012, and they were enforceable beginning in June of 2015. Now, with this new standard, it focused more, like I said, on hazard classification, a new labeling system. We went from material safety data sheets to just safety data sheets with the new 16-section format, and it also talked about important information and training in there. Now, fortunately, thanks to that 2012 revision, the new hazardous communication system and global harmonized system combination has saved lives and money. As we can see on our slide here, it has saved approximately 43 lives per year. Obviously, we want that number to be zero, zero fatalities or injuries, but this new standard is helping significantly, especially with injuries as well. It's saving an average of 585 injuries or illness per year. Okay. Now, with injury and illness, when you lower those, you also are going to save money, which is very important in the industrial world that we are in. So, been been, since the new standard has been implemented in just 3 years. So it was written in 2012, implemented in 2015. There has been $475 million in increased productivity. So that right there, not only do the decrease in deaths or injuries and illnesses a huge benefit to this new standard, but also the increased productivity, because when people think they're safe, they're going to work safer, they're going to work harder. You don't have to worry about people getting hurt. That goes into increased productivity, as well as a $32 million cost in savings between time off and equipment and different things like that that were caused because of injuries or illness. So as we can see, the hazard communication is very, very, extremely important in all of these industries. Okay, so now we've talked about that. What is a hazardous chemical? A hazardous chemical is any chemical which is classified as either a physical or a health hazard, a simple asphyxiant, a combustible dust, a pyrophoric gas, or a hazard not otherwise classified. Now, what we're going to focus on today mainly are the two main classifications, which are physical hazards and health hazards. Okay, so physical hazards. What do you think of when you think of a physical hazard? Well, a lot of us are going to go ahead and think of a fire, explosion, or a violent reaction. Okay, those are physical hazards that chemicals can cause. Now, examples of these are, you have things that are air reactive, they can be water reactive, they can be reactive to other chemicals. All of these can cause those physical hazards. And, a good example is, organic peroxides. A lot of those have to be cold. They have their temperature controlled, meaning they have to remain within a refrigerator or even a freezer, depending, and that way they don't self-explode or violently react. So that's just an example of those, chemical and the potential physical hazards present. Okay, so these are other physical hazards here as well. We obviously, have combustible liquids as well as flammable liquids. You have compressed gas and explosives. You have those water reactive, sodium, potassium, metals. If anybody's ever had fun in a pond and thrown a chunk of sodium into it, it makes a big explosion. Well, those are the kind of classifications we need to look at when we're storing and handling chemicals. So it's something to think about as well. There also are flammable solids. There are some flammable solids out there that will spontaneously combust. So we have all these different types of physical hazards that can harm us and our facility and the people around us. So that's definitely one of the big things we want to focus on, are those physical hazards that are present with whatever type of chemicals you're using in your facility. Now, besides physical factors, we're going to have health hazards. And with that, we most prominently are talking about acute problems or chronic problems. So short-term versus long-term. Health hazards are chemicals that are harmful to your health that once again causes acute health problems or those chronic health problems. When you think of acute problems, you're mainly thinking of dizziness, tired, maybe a fever. When you're thinking of chronic, though, that's more of mesothelioma, cancers, silicosis. Those are those chronic long-term problems that you're going to get from being exposed to a certain chemical. All right. So here are just a couple of examples that you probably see you can see almost every day, or at least heard of that are health hazards. So a lot of people use the chemical ammonia in their home as a cleaning product. You can get an acute sickness from ammonia. You can basically, from a high dose all at once, you can get nauseated, you can vomit, you can get dizzy, you might even get itchy eyes from the ammonia even. So that's just an example there of an acute chemical that can cause, acute problems. Thinking more now of maybe silica or asbestos, they have more long-term effects. It's a regular dose for many years or an extended period of time. It can cause those long-term or those chronic effects, such as silicosis if it's silica, or some types of cancer as well with other chemicals rather. And then unfortunately, some chemicals have both acute and chronic effects. A good example of that would be carbon monoxide. So just make sure we're paying attention out there to those physical and those health hazards, especially because, as we can see, some cleaning products that you normally use in your home can cause acute problems, as well as there are some things chemicals or different materials used that can also cause chronic problems. And unfortunately, there are some that can cause both at the same time. Okay, now health hazards continued. So OSHA's regulation pretty much calls out health hazards to be any chemical which is considered toxic, corrosive to the skin or eyes, is a respiratory irritant, anything that might cause cancer or birth defects or reproductive issues, chemical that specifically attacks an organ. A lot of times you'll see them attack the liver and the kidney, as well as sometimes the reproductive system like we've talked about. Or if it is harmful or deadly when inhaled. Those are those poison inhalation hazards that you have. Unfortunately, in some labs and in some facilities will keep those because they're good for reactions, but they're bad for human consumption. So just be aware of those as well. Okay, so now we're going to talk about the 5 ways of how chemicals enter your body. Okay, they're routes of entry. Ingestion, obviously swallowing the chemical. You have inhalation, which is breathing it in through the nose and the mouth. You have the absorption through the skin. Usually it's going to soak through your hands most likely, but any part of your skin is definitely a way for a chemical to be absorbed. On the skin or eye contact, you'll see that with some corrosive materials. We'll get into more specifics about that here in a minute. And also injections. Maybe one of the lower likely things to occur, but sometimes you might have a sharp that you've been using to inoculate with, maybe a mouse if you're in a lab, or a sheep or something, and it could have a chemical on it, maybe even a cyanide, depending what you're doing in the lab, what you're doing in research and development. So you need to look out for injection from sharp objects such as a needle, a needle prick, or a sharp piece of glass that maybe is broken. You need to be aware of that as well. A little bit more about ingestion. This is definitely one of the most common ones. And as you can see by that picture that we have up here, you can pretty much figure out why. Unfortunately, when a lot of people are working outside or working within a plant or something, they don't like to wash their hands. And unfortunately, then they go out to lunch, they grab their water bottle, they go out to smoke, they throw in some chewing tobacco, whatever it might be, well, they're ingesting it. They're ingesting that chemical at that point. So just remember, chemicals can rub off your dirty hands and contaminate your food, drinks, or tobacco products. But also, try not to leave any of your food or drinks or tobacco products, for that matter, out in the open, because what can unfortunately occur is those chemicals in the air can settle on the food and drink and then be swallowed. So make sure you're not, obviously we're washing our hands, we're keeping ourselves clean, we're wearing the proper PPE, and maybe even just decontaminating ourselves before we eat. But also keep in mind, if you leave those food and that drink, or those tobacco products even, or whatever you might be ingesting, out, unfortunately, depending with what you're working on, if you're working with, some sort of vapor, something that has a vapor to it, those particles can land on your food and your drinks, and you can ingest them. So please just be wary of that. A lot of companies don't allow you to eat near the floor for that specific reason. Okay, so inhalation and breathing, definitely one of the most common ones as well. Simply not wearing proper respiratory protection is one reason why you might inhale something. Or just walking around doing your normal task, whatever it might be. Vapors come up. Gasoline even has vapors. They're pretty simple chemicals we use every day that unfortunately people inhale from their nose or their mouth. And unfortunately with that, sometimes people don't even recognize that they're there until it might be too late. So definitely try to be on edge for that. Make sure you're aware of what chemicals you are working with, your plant works with, and who people around you are working with at the same time. So it's important to remember that those chemicals can settle in your respiratory tract, causing pulmonary problems. But unfortunately, when you get into pulmonary problems, a lot of times you get into cardiac problems as well. So the cardiac system and the pulmonary system pretty much work hand in hand with one another with oxygen. So when you hurt one, chances are you're going to hurt the other. So by exposing your lungs, you might also be exposing your heart to more stress. All right. So just make sure you're paying attention to that as well while you're breathing in the area. You have the proper dust mask on, or you at least have looked at your SDS and you know if it's a respiratory irritant or whatnot. So the next one we're going to talk about then would be skin absorption. So skin absorption, solvents and pesticides is so easily absorbed through your skin. So is gasoline, acetone, If you're working with paints, a lot of times you might be using, some people use gasoline to clean up their brushes, or even their hands, or if you're using a solvent or a paint thinner. Those can very easily absorb through your skin. I have had the experience, unfortunately, myself, of stripping my my wife and I just finished, actually, we were stripping our stairs, and I was using a stripper, and I had on gloves and everything. Well, I had a hole in my glove, and a little bit of that stripper I was using absorbed through my skin, and unfortunately for me, or fortunately at the time, I didn't notice it, it didn't hurt, but now a week later, I was starting to lose a little bit of the skin on the top of the tips of my fingers. So that's a good example of making sure, well, it's a good example, unfortunately, of how your skin can absorb something and you might not even notice it, and then the effects you might feel of it later. So definitely make sure you've got the proper PPE on, proper gloves on per chemical. Chemicals, are different. No chemical is one glove fits all, or there's no glove, rather, that fits all chemicals, unfortunately. So just make sure that you're looking out at your hands or even your arms if you need to be wearing arm protection or a tie, that whatever it might be. Unfortunately, skin absorption is another route of how chemicals can enter your body. All right, so with that, we need to talk about skin contact with corrosive materials. Now, as we can tell from these pictures, the picture all the way on the left shows a chemical burn immediately after it occurs. So the person must have stepped in some sort of corrosive material, and then a day later you can see the foot's worse, and 7 days later after that you can see the foot is way worse. So we need to remember, if we come in contact with corrosive materials, they don't stop just because you wash them, unfortunately. A lot of the times when you absorb it through your skin, perfect example, just like my fingers happening a week later, you can start to lose your skin or other parts on the superficial surface of your body, basically. So obviously they can cause skin burns and damage, and the extent of the damage, back to high school chemistry class, depends on the molarity or the concentration of that acid or of a base. And that's something, too, guys, to remember when you're thinking about it. Bases also burn you. Don't just think it's acids, okay? Acids below 2.5 and below will burn you, and bases 12.5 and above will also burn you. So just make sure that you don't just think it's acid, because bases can do the same thing as well. So just keep that in mind when you're working with those. Another contact point would be in the eyes here. We can see in this picture, unfortunately, I apologize if it's too gruesome for you. We have an acute chemical burn in the eye. When you inhale corrosive vapors or mist, you can also then get lung issues, pulmonary issues, which once again can lead to possible cardiac issues. So kind of a double-edged sword there, unfortunately, with corrosive materials. If it touches your skin, it's going to burn you through absorption, but it can also get you through inhalation as well. And that's important to remember, because a lot of chemicals out there that you work with can do both of those, or do multiple different types of the 5 ways of being ingested or being brought into the human body. Okay, so the last one we're going to talk about then of how chemicals enter the body is injection. Now, unfortunately, if you're doing some work with mice or sheep or whatever you're working with, maybe a sharp piece of glass of a beaker that broke. You just need to make sure that you're aware of that and you stay mindful of that, because chemicals still can pass through that needle into your skin. So definitely one of the lesser hazards of how chemicals enter your body, but something you definitely need to be aware of. Okay, now with that, we have the chemical toxicity. We have our chemical exposure limits. OSHA has set up the PELs for a bunch of different chemicals of what you can be exposed to. These levels must be both. You must be below these limits in order to be considered safe. Now, the PEL stands for that permissible exposure limit. And a good example of a chemical that is commonly found in gasoline and paint and a bunch of other stuff is benzene. Now, if anybody here has ever worked on a refinery, you know how much benzene is tracked. Well, benzene's PEL is 1 part per million. Okay, that's not very much at all. There's a lot of other chemicals out there that are worse than benzene, with lower parts per billion, even with a B instead of a million. So make sure on the safety data sheets, which we're going to get into, you look that up and you see what your PEL is, or what the you can maybe find it on the SDS, but you can also find it through OSHA's regulations on a specific chemical. So make sure that you're looking those up, especially if you're exposed to some pretty nasty stuff on a regular basis. Okay, so responsibility. So we've talked a little bit about responsibilities from an employer standpoint. We're going to get more into that, but also from a chemical manufacturer. So what does a chemical manufacturer have to do when they make a new product with a new ingredient, or they make a product for the first time? Well, they need to evaluate the hazards of the chemicals, if it's a pure chemical or if it's a mixture of chemicals in a product. Okay, they have to evaluate that and see what a bunch of different factors are, which they then put into the safety data sheet, which has now replaced the material safety data sheet. Now we just have SDSs, and those are required to be developed by those chemical manufacturers, and they are required to be sent on the first shipment by that chemical manufacturer to the person who's buying that or the person who's receiving it. Now the same thing goes for importers or distributors. They have to provide the proper labels in SDSs whenever they ship chemicals. Now, chemical manufacturers are required to send that SDS on the first shipment. A lot of times it's going to be if you have a drum of something or a tote, if you're getting a large quantity of it. A lot of times it's going to be in a packing slip on top of the chemical. I'm sure everybody here has seen that. Now, they are not required to continue to send that to you unless they change something in their product. Say maybe they use a new chemical, they take a chemical out, it becomes less toxic, it's no longer hazardous, it's become non-haz, or it's gone from non-haz to hazardous material. But at that point, then they are also required to send you a new SDS as well. And it's your responsibility then, as the receiving end, to basically hold on to the SDS and replace the old ones, which once again we will also get into. Okay. So now we're going to talk about the 5 employer requirements. So as an employer, what are you required to do? The first one, you have to create a hazardous chemical inventory. All right, we'll get into that. You have to ensure each chemical has the new GHS-style safety data sheet. We have to ensure each chemical container is properly labeled. Remember, once again, in 2012, we changed those labeling requirements. We need to create and implement an employee training program. How are we going to train our employees? How are we going to keep them safe? Let them know what they need to do in an emergency situation, or how to just even use those chemicals throughout the day. And then we have to develop a written HAZCOM program here as well. Okay, so moving into that chemical inventory. So when a chemical arrives to your site, it's your responsibility as an employer, as a receiver, to make sure that it has an SDS sheet. Okay, there should be one passed along with it. Like I said, it could either be on the drum or the tote or whatever you're getting it in, or the person shipping it or bringing it to you might also hand it to you at that point as well. Just make sure you get your hands on that. All right, and this information needs to be added to your chemical inventory. Okay, you have to keep an updated inventory as well. What we recommend that you do, what we do every year for our clients, is we go out and we do a chemical inventory audit. Okay, so we set up those nice safety data sheet books, or we've done an online system alphabetically for our clients, based on the chemicals they have. Well, then every year, because we all know you will inherit more and you also lose some chemicals. It's just the nature of the game. Well, we come in, we take pictures, and we take an inventory of what you have, and then we compare it, we audit you based on what's in your book. So we compare that to the table, or the index rather, of what you have. So that's a good way to keep an updated inventory that you need to do every year. And OSHA does require you to keep an inventory of all of your hazardous chemicals. Now, they only require hazardous, but I recommend non-hazardous as well, just to keep yourself complete. Okay? So with that, I'm going to pass it over to Rich, who's going to talk about safety data sheets.
Thanks, Zach. When you start talking about safety data sheets, really what I want to focus on, I'm pretty sure that we're all familiar with safety data sheets, but when OSHA came back in 2015 and they made these, or started enforcing these changes, some of the stuff that they did was really geared more towards helping us find information a lot sooner. First thing that they did is they made them into a standard 16 section format. So now that I know that if I want to go look at hazardous components, I go to section 3. If I want to look at PPE, I believe that's section 9. So it just makes it a lot easier for us to find the information that we need. And they also, along with, you know, creating that 16 section, you know, specified format, that they did is they also kind of started dictating what information needs to be in some of these sections. So what that's done is that's helped us understand what the hazards are, what the controls are of our chemicals are, so we can prevent, you know, employee exposure or overexposure. One of the things I do want to talk about is the accuracy of safety data sheets. Okay, and I'm going to use some antiquated data under the old system. You know, prior to 2015, you know, we didn't have safety data sheets. We had material safety data sheets. And in 1987, the American Industrial Hygiene Association did a study. I think it was about 135 safety data sheets that they pulled up at random, different manufacturers, different companies, different chemicals. What they found is that 47% of safety data sheets had bad information on them or were inaccurate on four very key components: occupational exposure limits, protective equipment, first aid, and there's another one that isn't as important. And the reason that I want to talk about that is because so much attention is given on when we're talking about HAZCOM on safety data sheets that we kind of created this perception that they are the end-all, be-all. They are it, man, when it comes to chemical safety, and that's not necessarily the case. And anybody who's ever looked at a safety data sheet, and I don't know if there's anybody on this call that has outside of training, but if you look at the protective equipment, and let's say that, you know, to use Zach's example earlier, he should have wore gloves when he was using a stripper. Or he did use gloves, but they had a hole in it. Yep. Well, now the challenge, I'm going to challenge Zach, is how do you know that you had the right gloves? Because if you look at a safety data sheet, all it's going to say is use rubber gloves. And what I found in my experience is that when I tell somebody they need to use rubber gloves, the first thing that pops in their mind are those yellow kitchen gloves that you can get at Kroger's or Walmart or Safeway or wherever. So that's where we're coming from, is sometimes this information isn't 100% accurate. Or, you know, hey, I got a chemical, I need to wear a respirator. Or it says I need to wear a respirator. What type of respirator? Do I need to wear a full face? Do I need to wear a half mask? Do I need to wear a P100 filter or an organic vapor filter, an ammonia filter, an acid gas filter? All it tells me is, hey, use NIOSH approved respirator in areas that aren't well ventilated. Well, so it tells me, but it doesn't give me all the information that I need from an industrial hygiene perspective to really evaluate my chemicals. Some of the other resources that we have out there are NIOSH, and specifically the NIOSH Pocket Guide, which if you're interested in that, you can get that at www.cdc.gov/NIOSH, National Institute for Occupational Safety and Health. Also, or you can use my favorite tool, that's called Google. And then the last thing you can do, or another important thing that you can do, is pick up the phone and call the number on the safety data sheet to get more information. Now, my tip to you guys is when you call that information, or you call that number, what I want you to do is I want you to ask for tech support or ask for the chemist. Don't ask for customer service. Customer service has been trained to not answer some of those questions. You get to the techno geek, the chemist, the scientist, the engineer, whatever, they're typically a little more forthcoming with, oh yeah, you can use it for this, or this is the type of glove you need, or this is, so you get a little bit more of the chemistry, so you get a lot better information. Safety data sheets are required to be in English, or other languages are permitted, but they must be in English. What I want to caution you guys on is I am seeing more and more, if we don't have something like a safety data sheet or a sign in English, and we have a very large contingent of non-English speaking employees, OSHA can still issue citations under the general duty clause. So don't get hung up on that, that they have to be in English. They really should be in any language that is prevalent or predominant within your workplace. And the last piece is they need to be readily accessible in the workplace. Okay, a couple things here. What OSHA has said is that readily accessible means I should be able to get to them easily within about 5 minutes. Okay, which means I know where to go get it. I can go find it. Which brings us to the question of online safety data sheet storage. And I know Zach alluded that we've actually gone this route for quite a few of our clients now. And the issue is, if you're going to use an online system, you have to have redundancy built in. For example, our system is a cloud-based system. You can access it through your desktop. It's downloaded onto your desktop, so it syncs with the cloud on a continual basis. So as long as you have electricity, you can get to it on a desktop. As long as you have a battery backup on a laptop, even if electricity goes out, you can use that. And it also has an app for a phone or an iPad or a tablet, any type of tablet. So supervisors, shop foremen, folks like that can house that or have that with them at all times. And the general consensus is, look, if electricity goes out, and we also lose cell service and cell power, we've got a lot more issues to worry about aside from you guys needing a safety data sheet. So that's where we've built in that redundancy to make sure that supervisors can get to these things. And again, we're doing almost within 30 seconds we can get to a safety data sheet, and we have that redundancy built in.
All right, thank you very much, Rich. And then as we can see here, guys, this is an example of the new format for the SDS. Just a quick snippet look into it. Up top in the left corner, you can see the NFPA rating. We'll get into why that is very important. And then, obviously, we can only see the first two sections of the safety data sheet, but just remember it's pages upon pages long, and there are 16 different sections in that as well. Okay? So what are those 16 sections in the safety data sheet? Well, one is going to be identification, you're IDing the product. Two is going to be those hazards identified. Three would be those composition or information on ingredients. Four, very important, first aid measures. What do you need to do if you become exposed to it, if it gets on your skin. A good example of first aid measure is if you're working with an acid such as hydrofluoric acid. Hydrofluoric acid will burn right to your bone. The only reason it stops at your bone is because it reacts with the calcium in your bone, and that's what stops it. So, for example, on something like that, the first aid measures is going to be to have what's called calcium gluconate first aid cream, basically. If you have that chemical around, you need to have that calcium gluconate all around as well, basically because the cream carries calcium in it and allows the acid to react with that instead of your skin. So that's an example of first aid, as well as if you need to induce vomiting or drink a glass of milk or water, depending on what the chemical is. All right, number 5 is we got firefighting measures. What type of fire extinguisher you should use. Section 6 is accidental release measures. 7, we've got handling and storage. Once again, with those organic peroxides that need to be that are temperature controlled, for example, and need to stay within a fridge or a freezer at all times. I'm going to talk about that in section 7. Section 8 is going to tell you about exposure control and personal protection, such as PPE. Section 9 is more physical and chemical properties of the chemical that you're using. Section 10, very important, about stability and reactivity. Is something unstable? Is it reactive? Is it non-reactive? Is it reactive when mixed with other chemicals or water or air even? You know, what are we dealing with? Maybe something that's radioactive even. Section 11 is the toxicology information. You know, what you get exposed, what's going into your body. And then sections 12 through 15 are actually not regulated by OSHA, but they have more to do with RCRA and the EPA as well as DOT, because they're more of that regulatory information, transport information, disposal considerations. You know, what do you need to do when you have chemical waste? Once that you're not using that chemical anymore and you determine it as waste, those sections will tell you how to dispose of it properly. All right, and then section 16 is just other information that the chemical manufacturer might find or deem worthy for you to know. Okay, so section 3 is labels. Those have definitely changed and been enforced since 2015. Now you're required to have a pictogram on your label, as well as a product identifier, a signal word such as danger, hazardous statements such as toxic, you know, when swallowed, flammable liquid, and flammable vapor, a general precautionary statement, and then as well as the chemical manufacturer or importer's information, and how you can get a hold of them if there's a serious issue as well. So focusing a little bit more now on those pictograms, they're extremely, extremely important, as we can see, because each pictogram represents something, something different. So as we can see, you know, the flame means something's flammable. The circle with the flame on it means it's an oxidizer. We've got our skulls and crossbones, which means it's toxic. The hand without a glove on it for being corrosive, and so on. So it's basically a quick look. You can tell, and you can see basically what the chemicals' properties are right away just from looking at the label, which is one of the main points behind those 2012 new regulations there. Okay. So those labels are also required to be legible in English, prominently displayed, and they must have pictograms like we've talked about. Now, prominently displayed, you need to make sure if you have a hazardous waste accumulation area, or you have an area where you just keep maybe your paint or your solvents, whatever you're using, make sure that those labels are faced out. You know, if it's up against a wall or something, or on a storage, a spill containment perhaps, just make sure that those labels are turned around, they're not turned towards the wall. That way, anybody who walks by can basically determine, or at least see the label and know what's in that drum or that bucket, whatever it might be. Okay? Now, relabeling, when it comes to relabeling, there's a couple different scenarios we're going to go through. The first one is, say, you know, you've got a product that's about 20 years old. It's still a really good product. You really want to keep using it. But unfortunately, you know, the label's out of compliance, okay? Because of these new standards, they're out of compliance. Well, at that point, you can choose an OSHA-approved label in your workplace and relabel that chemical and continue to keep it, you know, properly. But just make sure you're putting that new OSHA-approved label on it. As well as, say you have a 55-gallon drum or something, maybe it's halfway full, and it's got some resin in it, for example, like the picture we've got here. So you have a large quantity of chemical, and you need to break it down into smaller ones because, say, you need that resin throughout your entire facility. You can put it into smaller gallon jugs or quart-sized bottles, whatever it might be, that's fine. But at that point, make sure you're using that new labeling system and you're relabeling it with that OSHA-approved label, all right? Another scenario would be secondary containers. So we'll move on here to secondary containers. You know, the only time you don't need to relabel a secondary container is if you are the only person. You have to meet two of the following. You have to meet both of the following criteria. Okay, you have to be the only person using it. All right, that chemical, and you have to use it by the end of your shift. If you don't meet either one of those, you have to relabel it. But you know, say we're back here in the spray bottle, for example, and I'm gonna fill that with acetone for some reason to do some sort of job. And I'm going to use that entire spray bottle throughout the entire day, and I'm going to have it right on my hip or right next to me. Then I don't have to worry about relabeling it. But say me and somebody else are going to be using it, or we're not going to use it all up by the end of the day. At that point, then we would need to put a secondary, a new label on it rather. And the labels have to include what the chemical is and the warnings And we definitely recommend either using the NFPA or the HMIS system. Okay, so with that, we'll talk about the hazardous material identification system. The HMIS labels, they're pretty self-explanatory. They're color-coded, but as well as they tell you what each section means. We've got health, visibility, reactivity, and PPE, as well as the top is the name of the chemical. Now, they're on a range from 0 to 4, 0 being no hazard and 4 being a high hazard. And this is what one would look like from ethanol. As we can see, it's got all the proper elements to it as well. So what we use with our clients is this NFPA 704 system. It's very easy to use. You have to know that blue means health, red means flammability, yellow means instability, and white's different on this label. It's not for PPE, but it's for a specific hazard. For example, if something's corrosive, you could write COR in there for let somebody know it means it's corrosive. If it's water reactive, you can put a W in there and slice it in the middle with a horizontal line. That means something's water reactive. But once again, those are the same. 0 means there's no hazard, 4 means there's a high hazard. And once again, these are just simple labels. Down there you can see that show you what you're dealing with and let you know at a first glance what chemical, how dangerous the chemical is around you. Okay, so now we'll get into
Zach, I'm going to go back one thing on that. Okay, just want to make sure everybody's aware. We had a change come with the new HAZCOM regulation in 2015. And the NFPA 704 and the HMIS system were causes of a lot of discussion, a lot of public comment prior to issuing the final regulation. Now, if you go to Section 2, generally on your safety data sheet, that's going to start talking about hazards. You're going to see a number system where OSHA uses a 1 through 4 number system. Okay, the problem with that is for OSHA, when they're trying to determine whether or not something qualifies as having the danger tag word or a warning or whatever, they're using a system that's different than this. So in that situation, 1 is the most hazardous, 4 is the least hazardous. So when you're doing your training, as Zach's going to talk about here in a second, when you're doing your training on HAZCOM, you have to make sure that you call that out, because that's one area. I am a huge fan of the new regulation. I think it's done a lot to make the communication of hazard information easier to our workers. However, this is one that has created a lot of confusion. So just make sure that you're aware of that Section 2. Hazard rating system and your secondary system. This is also why on a lot of safety data sheets now, you will see the manufacturer actually put on the NFPA 704 diamond ratings. And I see that a lot more than I see the HMIS system, which is one of the biggest reasons that I like using this system better. It just seems to tie in more. So anyway, go ahead.
Yeah, so that's a good point too. I remember mentioning that earlier, but yeah, a lot of those safety data sheets now have this NFPA rating. So a lot of times it's either on the first page or the last page, and it's super easy to use. It tells you exactly what you need to put on those secondary containers as need be. So just like Rich said, though, make sure you're looking out because it can get confusing with that Section 2 and it being basically the opposite of what the NFPA or the HMIS are. So just be careful of that. All right, so training information. So we're required to train our employees on the HAZCOM standard requirements, what we've talked about today, what does OSHA require, as well as those hazardous chemical locations, okay? Where do we have those chemicals at? Our people need to know that in case they're working around, there's a spill and they step in it or what have you, they need to know what's around them. They need to be trained on that chemical inventory, especially when you get into a big facility, a big manufacturing facility. A lot of times you'll see people would just order different chemicals, whether it's something as simple as WD-40, which we definitely put in with our chemical inventory, to something as bad as hydrofluoric acid or acetone or something like, or methanol, something like that. A lot of times people will just order new stuff and not tell anybody. So we need to train them on the fact that they need to let people know, maybe your HR, if you don't have a safety department, letting them know you know, hey, I'm ordering something new, we need to put this in with our chemical inventory. We also need to train them on those safety data sheets and the new labeling, because, you know, your workers are the ones who are receiving that information in, and they need to be able to look out for it when they're receiving something at the shipping dock or what have you. They need to make sure that everything has those proper labels and comes with that safety data sheet. Then you have your written HAZCOM program. Your employees need to know the elements of that, which we're going to talk about here in just a moment, but you'll need to train those employees on that as well. And any specialized chemicals you might have, like I said, temperature controlled or things that are reactive with water or air would definitely be a great area to hit with your employees so they know what they're dealing with. Okay? Now, the written HAZCOM program, you know, it documents in detail what your plans are for communicating those chemical hazards, because that's what the HAZCOM program is all about, is communicating those hazards those employees are exposed to. Okay? And you have a right to review the HAZCOM program whenever you want. That goes for all employees as well. As Rich mentioned earlier, you know, your safety data sheets have to be readily available for any employee. Well, that goes for your HAZCOM program as well. They have to be able to review that if they so wish. Okay. Last couple of things to talk about within that hazard communication program. It is going to call out a list of the hazardous chemicals present on your work site, where you're storing your safety data sheets, you know, where you're storing them at. Labeling of chemical containers is also going to be, you need to call out what you're going to use, if you're going to use your own system, if you're going to use the HMIS, if you're going to use the NFPA, whatever labeling system you're going to use for secondary containers specifically, you definitely need to call that out there so everybody knows what's going on. And then, of course, training programs in regards if there's to hazards of chemicals and the protective measures against them. Those need to be covered in your hazard communication program as well. Okay, just a couple of things to think about real quick here before we finish up about staying safe. These are some simple things you can do to stay safe when working with chemicals. A lot of manufacturers now don't allow you to wear jewelry, especially if you're working with chemicals, because unfortunately, if you're working with some caustic or corrosive materials, it can potentially, if you have a ring on, if you're married or what have you, or if you're not, you just like wearing rings for that matter, it can potentially, you know, corrode the metal to your skin, unfortunately. Also making sure that you're using, you know, eye and face protection when recognizing the hazards is definitely in there as well. Cleaning, storing your safety gear properly, making sure it's not in a wet, cold place, making sure it's in a dry, safe location where it's not going to get run over or anything like that. And make sure, like we talked about in the past here, after you're using a chemical, make sure you wash your hands, okay? We don't want you taking anything with you to lunch or home with you either, okay? Also, we've got, you know, other simple actions, or know where the nearest eye wash station and emergency shower are located. They should be right near any caustic material that you might have. Dispose of hazardous chemicals properly via local and local regulations as well as state regulations or national regulations. Make sure you're disposing of those the way you need to be. You're not just throwing acid down the drain, so to speak. And know how to deal with spills and leaks, whether that's you have your own spill team or you have a contract with a company who will come in and clean up spills as well. And with that, make sure you know how to respond in an emergency situation as well. So with that, it's been a pleasure. I'm going to hand it back to Rich.
Hi, if anybody has any questions for Zach, please type those into our chat box. I see a question came through. Let's see here if I can get to it. There we go. Okay, we're recently notified that MIOSHA changed their guidance on eye washes. Now they not only require them for chemicals with a GHS classification of 1 corrosive, but also for those classified for the eyes as 2A. Many safety data sheets do not have an eye damage/irritation rating in section 2 or say not classified. Would it be safe to say these chemicals are not a 1 or a 2A for these chemicals, or would you question the safety data sheet? Yeah, I would probably, if it was me, I think we're okay to assume that If there's nothing in there, that they are not a class 1 or a 2A. Some other things that you can look at, I'd be interested in taking a look at, and I don't know the numbers, as far as what classifies each number off the top of my head. I have to look that up. But another thing that you can do is also look at the pH to see if it is considered acidic or if it's considered corrosive, either on the acid or the base side of the pH scale. But you can also look at that and then see where OSHA kind of draws the line. I think that would probably be your best bet to do those two things, because even if it's not there on the safety data sheet, it is still the employer's responsibility to make sure that you assess the chemicals. So thank you, Lisa, for that question. If there are no other questions, and I don't see anybody else typing, we're going to go ahead and wrap up. I do want to remind everybody of our free webinar series. Keep checking our website to see what we have coming up. Also on the right-hand side, you can see the open enrollment classes that we have. In fact, this Wednesday, we're doing a kind of an add-on to this class, the Fundamentals of Industrial Hygiene, where we get into a little bit of a deeper dive on how to evaluate employee exposures, especially from the chemical sense. So with that, and no other questions, I'm going to go ahead and wrap up. So thank you all very much, and have a safe day.